Morning, welcome to the Alternative Energy Forum. I'll start by letting the guests introduce themselves. Keith?
All right, I'm Keith Alon. I'm the CEO of Powerhouse Energy Group. We focus on extracting hydrogen from end-of-life plastics and end-of-life tires.
My name is Paul Atherley. I'm the CEO of Berkeley Energy. We're building the only uranium mine in the world today.
And I'm Andrew Bell. I'm the chairman of Regency Mines and Red Rock Resources. And Regency Mines and Red Rock have investments in some energy metals and beginning to invest in some technologies.
Great. I mean, to start with, just to give people an idea of the potential scale of the businesses, I mean, what size is the market at the moment and how is it growing and likely to grow in the future?
Well, the hydrogen market is there's about 60,000 tons of hydrogen generated every year. The vast majority of that is used in the petroleum industry today for refining. However, it's quickly becoming a fuel source, a road fuel source for hydrogen fuel cells and for stationary fuel cells. There are about 60,000 fuel cells shipped and delivered last year. That is expected to triple this year and to accelerate even more rapidly after that. Coupled with that, the transportation industry is making a bet in the billions of dollars, euros, and pounds range that hydrogen fuel cells are going to be competing with battery-powered vehicles, and in fact, more effective in many cases than battery-powered vehicles for transport use.
We have a market capitalization of around 150 million US dollars. We have 80 million US dollars in the bank, and we're building a mine that will, in full production in two or three years' time, will generate an EBITDA of $150 million. So we're fully funded into a cash flow producer on a, if you like, a PE of around 1 to 1.
Well, I appreciate what you're saying about hydrogen cells, hydrogen power, and for all I know, you may be right. What I can say is that at the moment, in, for example, China, public transportation, buses and public vehicles are being converted, or in many cases already are electric driven, and that's one of the main sources of demand for electric vehicles in the world today. Now, electric vehicles aren't necessarily powered by alternative energy, though it's easy to see that they can be. But the revolutionary thing about electric vehicles is what they can do, I think, to electric power and storage generally, is what they can do to transmission systems and the greater flexibility that will provide for all forms of energy. And clearly, the constraint that exists there, the thing that we're all looking at the moment, is the cost per kilowatt hour, where maybe you need to get down to $100 to get more uptake in the vehicle market for stationary power storage, despite highly publicized ventures like Tesla supplying Australia with a unit there. You actually need to bring the cost a great deal lower, to maybe $30 per kilowatt hour, as I understand it, to get much uptake there. So this is the sea in which we're swimming at present, and we know what's going to be comprising the materials in those electric batteries for the next 5 years, because the assembly lines have already been installed. What comes after, or where we go, my colleagues here have much better idea of than me, I'm sure.
I mean, how are you going to keep, your company's going to keep up with the development? I mean, obviously we're seeing, fairly new markets. Technology changes quickly. I mean, microchips probably a good example. I mean,
I think that's right. Look, I think that energy, like many other industries, is actually an ecosystem, and there's horses for courses, right? And I think that leveraging lithium-ion batteries coupled with a hydrogen fuel cell is probably going to make a lot of sense. as we start focusing and there's more political will behind the decarbonization of transport, decarbonization of public transport, there are expectations that we can't at this juncture build enough batteries to convert all of the fleets into bus fleets, for instance, into battery-powered vehicles. Hydrogen buses are seeing a tremendous uptake throughout the EU. The EU is providing a €200,000 rebate for every hydrogen bus that's purchased. And so I think that hydrogen that is generated from a low carbon source, as opposed to from steam methane reformation, will make a lot of sense. And it could well be that nuclear powered electrolysis ends up being the killer app for hydrogen generation. But that's a ways down the road. These guys have to build a mine, they need more uranium, et cetera, et cetera. In the meantime, we're able to generate a ton a day of hydrogen from end-of-life plastics, end-of-life tires, and a resource that's growing more rapidly than our infrastructure is keeping up with it, and that resource is called waste.
Yep.
I agree with Keith that the key issue here is decarbonisation. So the two massive trends at the moment, we're in this country, we talked about phasing out all coal-fired power stations in the next decade. At the same time, Michael Gove comes out and announces that we're going to have all electric vehicles by 2040. The National Grid puts its hand up and says, wait a minute, if we shut down all our coal-fired power stations the next 10 years, which we will, then we need to add another 30 gigawatts of installed capacity to our existing 60 gigawatts to create the electricity to power these electric vehicles that doesn't exist before. Because basically what you're doing is swapping fuel oil, whether it be diesel or petrol, for electricity. So two massive trends going on, and one constraint over this massive trend is society is demanding this new electricity all has to be zero carbon. So that overlay means that every sector, whether it be batteries, whether it be hydrogen, whether it be nuclear, is under massive pressure to deliver lots of zero carbon electricity. So if there's, from an investor perspective, if you can find any access to any part of this space, and I'm not trying to differentiate, it's a very good space to be.
Well, I'm not a great believer in the decarbonization thesis. As I think anybody who takes a longer-term view, the analytical view would be. I mean, you've all been and seen films like Jurassic Park, and you see these big flying dinosaurs, or you go to the Opal Museum and see big opalized skeletons of flying dinosaurs in Sydney. These birds could not possibly have flown had not the atmosphere been considerably more dense. And what we do know is that it was more dense because it had a lot more carbon gases in it. So the long-term trend is towards a cooling globe and towards a globe in which carbon gases are decreasing. And all we are at the moment is a tiny little way station along that. But the carbon fantasy that has captured governments through polytechnics and other converted new universities is something that will shortly run out. And when it does, the subsidies will go away. What it may have done that may be useful is it may have prompted people to take the next technology leap, because we do probably need to progress beyond the internal combustion engine to power cars. And the thing is that batteries had not had any real technological advances for far too many years. That's why Lord Hanson, when the Eveready Battery Company dropped the plot, lost the plot, and changed its name to Berwick, he seized on them, bought them cheap, cut out all the research and development, and milked it for cash for a number of years, because he saw there were no changes occurring. What's happening now is the amount of money being invested into these technologies means that the leap is going to be made, and that's going to change everything. So I predict that the emphasis on carbon-free technologies will disappear as the global warming illusion falls away from people's eyes. But what we'll be left with is some transformations. And this has happened before in history. For example, for 100 years after guns replaced the longbow still had greater range, greater accuracy, and greater penetrating power. It didn't matter. The change took place. And when it did, certain things like the high degree of training necessary for archers went out of the window, which meant you couldn't go back. I think something like that is happening now.
Right. I have to say that regardless of one's position about whether global warming is caused by man or whether it's happening or not, whether it is a fantasy, I think that there is political will and social will, whether it's based on a phantasmagorical perspective or not, that's going to stay. And so this idea that people are going to be satisfied with the continued increase in a thickening of the atmosphere that takes us back to the dinosaur days is not something that people are going to put up with.
I wasn't quite suggesting that.
Okay.
We're basically agreeing.
I'm sorry?
The change is happening anyway.
Change is happening, yeah.
I mean, what's going to make the general public want to move away from what they're using at the moment? I mean, in terms, obviously, they like the idea, generally people like the idea of moving on to something that's greener, but obviously, costs, how are you going to reduce costs to a level
we've
where...
reduced costs. The fact is that we can produce hydrogen. We're the only company in the world that I'm aware of that can produce hydrogen at a cost that's on par with diesel or petrol, right? Currently, the electrolysis produced hydrogen in the handful of hydrogen fueling stations here in the UK are selling hydrogen for about 10 pounds per kilo, which is effectively a gallon equivalent, and we can very profitably sell it for 5 pounds. And so all of a sudden, if that's a gallon equivalent, all of a sudden you've changed the market perspective and the efficiency and the number of parts associated with an electric vehicle. Keep in mind that whether you're battery powered or you're hydrogen fuel cell powered, you're still an electric vehicle which has dramatically fewer parts, moving parts than an internal combustion engine, substantially lower maintenance costs, longer life cycles, and quiet, clean. I predict that people are going to take that up because they're not going to have to change their behavior. Fueling a hydrogen car is as easy as showing up at a Bowser and filling your car with petrol. So I think that the more that you can keep things the same for people, the more likely they are to adopt it. And of course, people are always going to do what's in their economic best interests.
Yep.
And so the fact that we can produce a fuel that is on par with, the fuel they're using today, I think it makes it compelling.
Yep.
Look, my view is if there's a debate between liquids and electricity or electric motors, I think we're becoming more and more electrified, whether it be for generating power or any form of systems now. We're moving more and more towards electrification. So the trend for me would be how do you generate clean electricity to power that, and then this whole issue of storage and recharge. I think that's the area for me which is the biggest state of, to use a terrible pun, biggest state of flux. And we follow the Grantham Institute and the Energy Institute at Imperial College and look at their studies. And certainly there's a lot of money and intellectual energy going in to solve that complex mix between power generation, storage, transmission, distributed. That's where the current thinking, I think it's almost, for the academics anyway, it's a given that we're going to be more and more electrified in everything we do.
And that may be right. I think, again, you're looking at some countries like Germany that seem to be going against the trend, has cut back on nuclear, and have ended up by having to build new coal-fired power stations. But when we're talking about nuclear and we're talking about uranium, and that to me is interesting because I was talking about triggers for change. The trigger for change that brought in nuclear power stations was the Second World War and the huge amount of government spending and concentration of effort by physicists to solve the problems, which were physicists' problems, of harnessing uranium power. Now, what would be very interesting is there's another material that doesn't have the same weaponization capabilities, is much more widely distributed around the world, and easier to dispose of the waste, which is thorium. But the problems involved in thorium are chemists' problems, not physicists' problems. And when India was being subject to sanctions for letting off a nuclear bomb, they started developing the thorium and were trying to solve the technical problems involved in developing thorium reactors. And then, unfortunately, the sanctions were taken off them, and now they've gone down the uranium route like everyone else. But all it would take to get something that would take us from the crossbow to the gun, or from the, we're talking about from petrol power to electric power to maybe hydrogen. We've seen uranium come in. All that it would take for thorium to come in as a cheap, long-term, almost limitless source of energy would be enough spending, which is probably beyond the power of individual companies. So it either requires a great government effort or the stimulus in a war with a country that doesn't have access to uranium. But these are the things that should come in the future. And so I'm really hopeful about the future.
I mean, in terms of your own companies from a sort of investor's point of view, I mean, how close are you to sort of net cash flow generation from your business?
Our first commercial plant is expected to come online by the end of this year, 2018. Our intention is to roll out several additional plants next year, and then to engage in a land grab. And our intention is to be able to build in a modular manner these distributed modular gasification units that are deployed as fueling stations, hydrogen fueling stations. So we're looking at 1, 2, many.
We're 18 months away. We've got the money in the bank to build the asset, which we're going through that process now. We'll complete construction and commence commissioning towards the end of 2019. So you can say 2020 is our first full year of generating free cash flow.
I was talking earlier about the effect on transmission systems and of developing electric batteries, either for vehicles or for stationary storage of electricity. Talking about transmission systems again, we are involved in Regency, and we have an investment in Curzon Energy that's coal bed methane. Now, gas is gradually taking a bigger part of the US energy mix, which is going to affect prices. When that gas starts to build up and starts to be exported, it's going to affect prices globally. That's a cleaner burning fuel. But of course, in order for gas to replace other things, it needs to have a transmission network. And through government subsidy and encouragement of gas, over the last few years, the US has started to put that in, and therefore I think we're going to see a narrowing of the differential in what you get between gas and oil over the years, and that's going to be, so we're playing just a little subset of the technologies of change there, and we're benefiting from something that improves the transmission system for energy by transmitting a gas. In Regency, we also have one of the world's biggest nickel cobalt deposits in Papua New Guinea, and after a very long bear market for nickel, longer than any other metal, nickel is now starting to improve, and we have been talking to major companies who are interested in doing something with us, because just as Rio is starting to move into lithium, some of these companies that you wouldn't even think of are now looking at nickel and cobalt. We in Red Rock also have an interest in a manganese company that's just listed. Long term, I think manganese is going to start being important for electric batteries. In the foreseeable future, like the next 5 or 6 years, it's only going to be a very small part of the manganese demand, though a more substantial part of incremental demand for manganese. And we're also looking at some copper cobalt tailings in Congo, where I've just come back from. So we are looking at different aspects of this, and we're looking at things that can be in production, producing cash flow very quickly, except in the case of the nickel cobalt acid, which is a longer term strategic play because it requires a great deal of money to bring it into production.
So I just want to interject briefly because you mentioned the transmission infrastructure, and I think that is a gating factor throughout the industry, both for in terms of the adoption of electric vehicles and the adoption of hydrogen as a gas that's being used for homes. There are a number of tests that are ongoing, pilot sites that are ongoing throughout the UK. The UK is committed to upgrading its gas infrastructure to allow a higher proportion of hydrogen to be injected into the gas grid, which is going to allow for more hydrogen to start to be used as a fuel source for homes and things of that nature. Because even though natural gas is a cleaner fuel than coal, hydrogen, of course, is the cleanest fuel. And I do want to point out that the plastic that's contained in this bottle alone can fuel a hydrogen fuel cell and move a car 40 meters. So the ability to convert this stuff into something worthwhile exists, and this of course is a recyclable bottle, so you would recycle it. However, there's a lot of end-of-life plastic that is comparable, that very small amounts contain a lot of usable material.
Right. I mean, what sort of incentives are there at the moment from governments to switch over? And I mean, are there tax breaks in place or
there
incentives?
are there's a fuel subsidy for renewables in the UK. The EU considers end-of-life plastics, end-of-life tires to be renewables, as opposed to the UK, which does not consider it to be a renewable. But the EU has hundreds of thousands of euros set aside for grants for the decarbonization of public transport, for instance. We have a relationship with Wrightbus, a company in Northern Ireland that manufactures hydrogen buses and hydrogen fuel cell buses. And so we're looking at delivering turnkey solutions in tenders in the EU, particularly to eliminate the particulate matter that diesel buses are generating. These old fleets of diesel buses are causing Eastern Europe to have the worst air quality in the world. So I think that there's a substantial commitment, both politically and financially, in the EU to, one, engage in this decarbonization and find alternative fuels to manage their public fleets.
Paul, on your side of things, is there?
Look, my thesis is very simple. We need more clean electricity, and when the wind doesn't blow and the sun doesn't shine, you need a base load, and you've got a choice. Is it coal, is it gas, or is it nuclear? Batteries are not on a grid scale, as a seasonal, diurnal grid scale. Batteries are not there yet. They may be in the future. So you have a choice. The UK has clearly made its choice. It's going to have nuclear as a base load. The European Union has made a choice. 25% of its base load will be nuclear. The only country that has chosen not to do that is Germany through its Energiewende policy, and it's a disaster. Energy for Humanity, the NGO, described the $150 billion energy vendor experiment as a disaster. And the reason it's a disaster is Germany now, having turned off its nuclear plants, mines more lignite coal today than it does in 2010 when it turned it off.
Wow.
So I think for us, it's very simple. You want clean, scalable, more electricity, then nuclear has to be part of the mix.
But you also need upgrades to the entire transmission grid, I think, to handle the additional power requirements that, for instance, electric vehicles are going to require. And these are 20-year projects that the government is, well, that electric companies are having to commit to, and that the government is having to subsidize.
Just on that point, there is another debate, and it's probably beyond the scope of this, is about distributed energy systems. I think most people in the audience will be familiar with it. Yeah. Do we want large centralized systems that distribute electricity all over the UK or Europe? Or do we want to move to distributed systems where you have standalone systems that have a combination of solar, wind, battery, or even small modular nuclear reactors? So that's another debate. And I think the green argument is that we move away from centralized systems, we move to more distributed systems which have better ways of balancing the need, consumption and needs. And certainly, if you look at what's happening in California at the moment, they've gone a long way down that track. So I think the future is away from big grid-scale systems to much more distributed systems.
Just from interest, I mean, I know we think of nuclear power stations as being very large, typically. I mean, large in comparison with any other plant, and particularly large in comparison with, for example, a coal plant. And yet we know that it's possible to have miniaturized nuclear systems, because after all, that's what nuclear submarines are.
Exactly.
Is there any possibility you can actually have distributed nuclear systems?
Yes, it's a very good point, and it wasn't Dorothy Dix. I didn't mean, Andrew, to throw that back, but that's what George Osborne was pushing, and certainly the UK government, with Rolls-Royce, is taking exactly that technology and taking basically nuclear submarine technology to create mini, small modular reactors so that it can be part of distributed systems. So where nuclear will end up, I think, will be either end of the spectrum. You've got Hinkley Point B and C. Hinkley Point B and C will produce enough electricity to power London on its own for 70 years. If you ran a cable from this corner of this field in Somerset to central London, you could power Greater London from that one plant for 70 years. To give you some idea of the scale of that energy density, the biggest offshore wind farm in the world is the London Array. It's 100 square kilometers. That would power London for 6% of the time for about 20 or 30 years. So that's why nuclear works. It's called energy density. It is the most dense and efficient fuel. It's basically taking what's happening in the sun and putting it down here. So nuclear, and if you can do, as Andrew points out, if you do it on a small basis and make it socially acceptable, by the way, these Generation 4 reactors consume all the fuel. There's no waste. If you can get to that point, then that is a permanent solution to baseload. And then again, picking up on Andrew's couple of points, if you can go into an alternative fuel source, that's thorium, great, then there's no possibility of military capability. Or, as the Japanese and the Chinese are pushing really hard, if you move away from fission and you get towards fusion, then it's got automatic fail-safe. So I think the technology trends in nuclear are, in my humble view, the key to long-term baseload, scalable, clean energy.
Just as a question, because I really don't know the answer to this, in taking that energy from Somerset to London, what's the transmission loss?
I don't know what the grid losses are in the UK. But the answer to that would be, and I can answer it in this terms, is what the Chinese are doing. Grid losses are low because we have relatively low Ohm's law. We have relatively low transmission voltages. If you go to ultra-high voltage, as they do in China, the transmission losses are tiny. So you have very, very large cables going over very large distances. The losses are tiny.
I should point out that that as of 2017, there were 42 startups in the United States alone, focusing on nuclear energy. So it's definitely, again, the concept of decarbonization is actually driving this. And I think that because of the fail-safe technologies that have started to come into being, people are starting to revisit the use of nuclear energy far more fearlessly than they have over the last few years.
Great. Any questions from the audience? We're sort of coming towards the end, so. It's fine.
I'm sorry?
Sorry.
Wood fiber?
Can I take that question?
Yes.
In part of the energy mix, if you look at the mix, biomass works because it does the one thing that the other ones don't. It takes carbon out of the atmosphere. So the reason why it's popular is you're basically getting a tree that's taking carbon out of the atmosphere. You are then generating electricity from it. And the thing that works is if what Drax is doing is you sequestrate that carbon. So biomass only works if you are able to sequestrate it. And the only place in Europe where you can really sequestrate it at the moment is in the North Sea and the Irish Sea. And the reason why the British government's pushing it very hard is that it could well be that the UK is the only country in the world that can actually take its carbon and put in EOR, end of oil field life, and permanently sequestrate. If the UK solves that problem, it makes biomass and all these things very exciting. It's a very interesting area. Drax is almost like the test bed for it. But the concept, I think, is it's biomass. It's taking carbon out of the atmosphere, turning it into electricity, and then taking that carbon and sequestrating it. It's the only technology that's, you know, the problem we've got with, if you accept global anthropogenic global warming, the problem is not the future carbon we're going to put out there. The problem is we've been putting carbon out there for 150 years. So you need, this is the one technology that hopefully will take some of that carbon out of there. That's why it's popular. Well, the Indians are, the Chinese aren't. The Chinese have announced they're hooking up 8 nuclear reactors this year. There's 57 nuclear reactors being built around the world today. I think it's 16 in China. There'll be another 20, 30, 40, 50. The only way the developing economies are going to decarbonize their economies is having nuclear as part of the mix. It's accepted. The Gen 4 reactors are super safe. That's the future. It's the emerging world that's doing that. The old world, you hear about Belgium closing a reactor and a reactor closing in the US. That's just history. The future is that. These coal-fired power stations that are being built in other parts of the developing economy is because they need the energy now. And that's the problem, that we can't build the nuclear power stations fast enough. And unfortunately, there are parts of the world where if you're north of 40 degrees north and south of 40 degrees south, unfortunately, there isn't enough sunlight for solar. And if the wind doesn't blow, you've run out of renewables. And so they're going, well, we need the power and the heat and the light. So it's just a fortunate stage that they don't want to build nuclear power stations, but they need the energy. So they don't want to build coal-fired power stations, but they need the energy now.
And they're actually buying used power stations from coal-fired power stations from China, and they're shipping them to Africa.
Yeah, so I think we've run out of time there. Just getting a nod there. Just remind
that gentleman had a question.
Us. Sorry.
They've been done at test level. We did actually build one in mothballed down in Dawson.
Right, if you just remind everyone which stands you're on, in case if anyone's got any more questions, they can obviously come and have a chat.
I don't know what stand I'm on. I'm Powerhouse Energy, AIM, ticker symbol, PHE. Buy now, buy often.
Berkeley Energy do the same thing, BKY.
I think we're stand 70-71 or 72.
Brilliant.
Thanks very much.
Thanks very much for that. Yeah, great.